All right. Thank you, everybody, for joining us. This is the Denver Code Club meetup here at Kenzen in Denver, just next to Union Station. I'm Daniel Williams. I work here at Kenzen, and I'm going to do a quick 15-minute quickie on platform, as this talk is part of our series on modern microservices. So we're going to touch a little bit on platform, and then I'm going to hand it off to Aspen Mesh, who will come in and do a much longer, more in-depth talk about the service mesh Istio. So I'll go ahead and get through mine real quick. We'll breeze through it, and then we'll have Aspen Mesh come up and be far more interesting than me. All right, I got to give the 30-second marketing overview on Kenzen. So we are Kenzen. We are a small consultancy here in Denver. We actually have locations in Rhode Island, in New York, in Denver, in LA, and now in Guadalajara, Mexico. So we actually spread out pretty good, about 120, 130 employees right now, spread throughout the offices. You're sitting in the Denver office here. We do everything as far as cloud goes. So we do front-end development, we do back-end development, we do platform, we do anything cloud-related, AWS, GCP, you name it, we've done it. And so we do a lot of stuff focused around deploying and maintaining media applications. So I think it says it on here. Yeah. Thomson Reuters, Charter, Cablevision, we've worked with them or are currently working with them to hand out media platforms, so a lot of the online streaming type platforms. We help build them and maintain them and that kind of stuff. So that's our bread and butter, but you name it, we've done it if it involves the cloud. All right, if you want to read more on this, this is on the GitHub for the modern microservices, like the previous presentation, and it's also being streamed online right now. All right. This is part of a multi-part series, so we're talking a bit about platform and infrastructure. The other parts that will be coming later, continuous delivery, continuous integration, and application. I believe next month is going to be on application, and then we're going to start building backwards through it because the application is the most important piece, and then we'll build up the structure around it. But because Aspen Mesh is here doing Istio this week, we kicked platform to the front instead of the back of the line, at least for a quickie, so we can go over some stuff and kind of lay some groundwork. Last meeting, I showed this diagram. It's a nice, simple diagram, but it kind of shows the pieces that we're going to talk about again. Platform at the bottom, and then continuous delivery, continuous integration, and application. So we're going to talk a bit about platform, and Istio is very much in here, service mesh. And it does a whole lot of magic and takes care of a whole lot of heartache down in the platform area. All right. The first thing I wanted to talk about in our platform quickie is containers versus virtual machines. It's a big question, and since containers are the cool, hot thing right now, Istio works in Kubernetes. A lot of other things work in Kubernetes, and Kubernetes is all about containers. Everybody's talking containers, containers, containers. Containers are great, but you can't forget about virtual machines. So virtual machines, right now, most of the industry is still using virtual machines. We work with a lot of clients. Most of those clients are just currently in the initial evaluations and initial deployments into container-based architectures. Their main horsepower services are all running in EC2 instances in virtual machines. There's lots of platforms, so VMware, AWS, GCP, Azure, Joint, Triton, DigitalOcean, Rackspace. I could name probably a dozen more. These are all big virtualization platforms. They all started out doing virtual machines. They're all expanding into the container area, but they're really good at virtual machines, and virtual machines are your bread and butter of your data space. One downside to virtual machines is inside of every single virtual machine, you have the full overhead of the operating system. Because you're running a full operating system, needs virtual machine. A good upside, though, is virtual machines are good at giving you lots of CPU, lots of RAM, and in particular, lots of disk. right? Virtual machines are geared towards running like a computer, so they give you a whole bunch of these resources. I'm going to run, as I show here, databases on virtual machines. But also, if I need some really CPU-intensive applications, I'm not going to put them in containers because I'm going to start eating Kubernetes nodes. Lots of overhead for small services. That's kind of the downside that goes in with the overhead from the full operating system. Virtual machines are pretty heavy for running this little teeny tiny thing. Containers. As I said, new and shiny. They are the thing everybody's talking about right now. They're fantastic for stateless services, right? Throw it out there, throw 2 out there, throw 10 out there, throw 1,000 out there. They're great. They spin up, they grab their configuration, they just start doing work. They're happy as can be. Containers are fantastic for that. A lot of it is because they share their operating system overhead with all their other container friends sitting on the same node, right? So you save a lot of the overhead. Like I said, they're good for small to medium CPU and RAM requirements. But they're bad at long-term storage, particularly non-ephemeral storage, right? Caching, totally fine in a container. A big MySQL database or MariaDB database or SQL Server database, really going to tax your container architecture to the limits because those things need a lot of CPU, a lot of RAM, and a lot of disk attached. And disk is one of those things that they're working on with all of this container stuff, but it's not there yet. They're still trying to do it. The other thing that containers are currently bad at, doesn't get used very often, is this special hardware stuff. Graphic processing units, right? Your big NVIDIA CUDA chips, stuff like that. Also FPGAs. That's one of the new things AWS rolled out recently is in the cloud FPGA. It's special hardware, so it's hard to do with a container because a container is all about abstracting all of the hardware away. One thing, so with the virtual machines, right, there's all these different platforms that all do their virtual machines a little differently. A lot of them are kind of converging on the KVM Linux thing, but there's still 10 or 15 different kind of virtualization platforms. Most of the container stuff right now seems to be converging on the Kubernetes set of APIs, right? There's Docker and Docker Swarm, but most people that use Docker, they use Docker for their local development and then deploy it into Kubernetes. GKE, Google, Kubernetes, AWS just kind of, they didn't abandon their ECS, but they're now really pushing their EKS, their Kubernetes engine. Azure has a Kubernetes engine. Joyent has a Kubernetes engine. Basically, OpenStack has a Kubernetes engine. They're all kind of coming together on this Kubernetes thing, which is great if you like Kubernetes and if your workload fits into Kubernetes, but you don't get the variation in the market like you do with the virtual machines, where you've got all these different platforms that work a little bit better on certain things, but are all mostly the same. So the conclusion is, the ultimate cop-out answer, think about it and figure out what works best where. But to be more useful, I put my personal opinions up here, the way I tend to see things deployed and the way I like to deploy things. Use containers for stateless stuff. API gateways, ephemeral caches, transcoding, lots of compute, lots of RAM, very, very little as far as actual in-place storage. Use VMs, or for that matter, use built-in services to the cloud for your storage. So if you're running, you got to run like a big, heavy database, right? A Postgres, a MySQL, a SQL Server, an Oracle. Don't try containers, put it in VMs. It'll be a while before containers can handle those. Any questions? All right. And to give credit to the cloud-provided services, these are also other options you have. So a lot of permanent storage. You have, S3 or, well, I have Kubernetes here, but S3, Bigtable, things like that for the permanent storage side of things. But the cloud-provided services are really nice in both cases because you don't have to build it, right? There are times you're going to build things like your application you're going to want to build because that's your thing. If you can buy things, if you can just use the services off the shelf, it saves you a lot of time, right? The services are generally more expensive, but you save all of that on the number of people you have to maintain it and the amount of time you have to maintain it. So if you can, go the cloud provided services. Otherwise, think long and hard on VMs versus containers. Containers are good for 90% of your architecture, but when it comes to data, basically long-term storage, data at rest, VMs are going to be a better option. A quick primer, the 30-second primer, or probably 60-second primer on Kubernetes. For those who haven't heard, it's a container platform cluster. It runs Docker containers. It technically can actually run a couple of other versions of containers, but nobody talks about those because they're not very popular. It basically combines a whole bunch of stuff, a whole bunch of Docker servers into one big virtual Docker server, so you can run the application with a whole lot of redundancy and with the whole lack of heartburn about managing different servers. It's got some goodies in there, and one of those goodies is a plugin architecture, which allows us to inject things like a service mesh, which, as I worded it, a magical routing layer for controlling, monitoring, securing API calls between your stuff. Right? So Aspen Mesh is presenting Istio tonight, but there's a couple of others, and it handles all of these features that you're gonna need, but it does it more in a built into the platform way as opposed to having to specifically include it in your application way. Load balancing, gotta have that. Circuit breaking, really nice for doing fault tolerant systems. Service discovery is great for scaling. Telemetry and logging. If you don't know what's going on, you don't know how to fix it. So you gotta have those. And this pulls a lot of that back into the platform. So, are there any questions? I'm going to cut off on my technical stuff here. I'm going to give a couple of quick links. So a good document I ran into recently that talks a lot about some of the high-level things is this ACM article. You're building a distributed system. There's no getting around it. And everything we do nowadays in computing is building distributed systems. And there's a spot in here where he says, you're going to be building a distributed system to manage your distributed system. So that's what we're building, right? Distributed systems to manage distributed systems. So we need all the help we can get. This brings up a lot of good high-level points to think about. And then our capstan projects, like I talked about last time, and we'll dig into a lot more in the future. And then you know, the one I have to keep our marketing department happy, keep Alana happy. Here's all of our media stuff. And with that, we're going to go ahead and cut over, and I'll bring Aspen Mesh up, and we'll talk about Istio.
How should we do this?
All right. So.
Yep, I need that back.
I'm going to go ahead and I'll stop sharing. So if you hit the share button, we'll plug this in first. And then once it does screens, so go ahead and hit the little share button up top.
Is this mirroring?
Yeah. All right, if it's mirroring, then just, yeah.
Oops. Is this good?
Yeah, you're sharing the screen?
I think so. All right.
So then, yeah, just pull your presentation up and you're good to go.
All right. So hello everyone. I'm Neeraj. I'm the platform leader at Aspen Mesh. Thank you for joining me in exploring how you can simplify and standardize your microservices environment using a service mesh like Istio. So I was going to start off by a quick survey of questions as how many of you have heard of microservices, but because of Daniel's presentation, almost all of you have now. So I don't need to do that anymore. So I'm going to go to the second one, which also doesn't make a lot of sense, but I'm going to do it anyways. How many of you have used or are familiar with Istio? Again, Daniel gave a little bit of intro on Istio and service meshes. So, all right, I can see a few familiar faces now. So that makes sense. All right, cool. So let's make sure after the end of this presentation, if we are at a stage where most of us know what Istio is, and hopefully after the demo, we can even try it out. So the way I have structured this presentation is I'm going to first talk about what a service mesh is. what problems it solves, different architecture options you have, then move on to the Istio architecture, then the array of functionality that Istio provides, and then a live demo, which we'll see how it goes. All right, so with that, let's begin. So this is a typical microservices environment. You have three microservices, A, B, and C. A is talking to B is talking to C, and then C is talking over internet to maybe a hosted service like AWS or GKE. Just like any microservices environment, they're written in different languages. So A is written in Python, B is written in Node.js, and C in Java. Very typical of microservices environment if you are actually using it. So the key thing to understand in this slide is the green boxes here represent what is essential complexity, or what are the features which are essential to each microservices, which the developer of that microservice has to maintain. So this includes the business logic and the APIs which are unique to each microservice. There's no way getting around this uniqueness because that's what the developer actually writes. So if you're not using a service mesh, the developer of the microservice is also responsible for maintaining the gray boxes here. So the gray boxes represent somewhat common functionality which is related to communication between these microservices. So they include things like service discovery to actually find out your services, load balancing, circuit breaking like the functionality Daniel mentioned. If you're using tracing and telemetry, so if you need visibility in your microservices, you have to incorporate those libraries. If you are having mutual TLS or security, you will have an SSL library. Now, imagine you're an operator of this microservices environment and you just don't have 3 but 30, 300, I don't know, pick your number. It gets really complex really fast. So some of the problems as an operator is how do you inform and make sure that you have uniformity in this environment. So imagine I have to ensure that I have a minimum version of SSL library so that I'm meeting a security posture. Now I have to go and change 300 of my applications to ensure that. If I have to make sure that all my tracing, or for example, if all the request metrics that are sent, they are spelled the same way. So request count is actually request count, but not request underscore count. Again, changing all the applications. As a developer now, I'm not happy because not only am I maintaining the green boxes, but I'm also maintaining the gray boxes, which I don't really want. So you can see there are two kinds of problems that are presented if you're not using a service mesh. So this is what a service mesh solves. So it's a common infrastructure layer that handles and manages the communication between these microservices. It is inserted at an infrastructure layer in your network, so it's isolated from your application in that way. It is not inside your application anymore, it is in a container or it's living outside the application. So it is meeting the goals that I just described and solves those two problems. As an operator, I have the key infrastructure which I need to make sure the communication can be uniform. As a developer, I'm happy that I don't have to maintain and keep tabs on the code which I don't really want to do. So depending on, so there are the various architectural options that come up with service mesh. So typically service meshes provide these functionalities by inserting a proxy. So the proxy is responsible for intercepting traffic and is providing all the advanced communication functionality that I was mentioning or even Daniel was mentioning. So depending on where you place your proxy and how you insert it, those architecture options arrive, and all of them have some trade-offs. So I'm going to explore next what are the various architectures. Right. So the first architecture option is what we call a per node proxy. So this was pioneered by Buoyant, which is a service mesh from Linkerd. In this, a proxy is inserted on the node in which your microservices applications are running. So the proxy will intercept the traffic from your microservices, and then the proxy will reach out to any other microservice on any other node. In fact, for even communication within the node, sometimes it goes through your per node proxy. So now this model works great for many use cases. It has benefits around sharing of memory or sharing of resources, but it does break down when you want to reason about security, especially if you want to think about a workload and a proxy as one. So because this proxy is multi-tenant, the proxy will not be able to assume the identity of one particular workload. If you are a security person, you can think of cases where if one of the applications in this model gets compromised, it might compromise your proxy, which in turn might compromise all the applications running on the node. So it has advantages, but it has some severe deficiencies. Additionally, if there are some variations in requirements, so suppose if app B needs an OpenSSL version which is suppose different than app A, in this model you can't have that because the proxy is inherently multi-tenant. So these two problems are the problems which the next model solves, which is the sidecar proxy model. I heard of some chatter before I came here, so let's see if I can explain this. So the sidecar proxy model basically works where you insert a proxy as close to the application container as possible, but it is still outside the container boundary. So it's not glommed into the same application, but they're two separate containers. So let me go into details what it means if you're running this in Kubernetes, because I'm going to go further deep down and assume that Kubernetes is the platform that we're talking about. So if you're running Kubernetes, this means you will insert a sidecar proxy container in the same pod in which your application is running. So the proxy container and the application container are going to talk to each other over loopback. That loopback traffic is isolated from the rest of the world because it's in the container namespace. From the outside, you can view the sidecar proxy and application as one because they are part of a same pod networking. From the security point of view, you can reason about them as one because they are in the same networking namespace. So the sidecar can assume the identity of the workload. It can do the advanced security functionality that you need. Now, obviously, if it's a sidecar proxy model, you have to make sure that your sidecar is efficient. It has the right footprint, otherwise your things get heavy. It has the right performance because every time you're inserting the sidecar everywhere, you're losing some performance. So this is the model which Istio uses, and I'm going to go over Istio architecture next. So this lays down the groundwork why Istio is choosing the sidecar proxy model. All right, so lots of boxes. So this is an overview of Istio architecture. We have the familiar three services, service A, B, and C. We have the container around the green boxes, which is your application logic. In this, I'm showing another container which is inserted in the pod, and the sidecar proxy, which is shown here, is Envoy. So that is what you see in gray. Envoy is a very efficient proxy written in C++. It was initially developed at Lyft and is currently open source. So with Istio, what happens is envoys are going to intercept the traffic which is coming from, for example, container A. Then envoy will talk to the other envoy in service B, and then that envoy is going to forward the traffic to the application container. So all the envoys together, they're talking to each other for providing you the advanced functionality, and all the envoys together are what we call the data plane in Istio. So Istio has a very nice separation of control plane and data plane. The boxes in the top are the Istio control plane components. I'm going to talk about what they are because it's useful to understand those components as some of the functionalities are provided specifically by these components. So this separation of control and data plane is really powerful as an operator. It gives you the ability to independently upgrade and scale each of them. Additionally, the control plane itself is distributed, it is broken up into 4 or 5 components. So you have the ability to individually scale and upgrade them as and when needed. So all the components provide some specific functionalities and they are logically distributed like this. So the first control plane element is pilot. Pilot is the piece which looks at your platform configuration. So if you're running in Kubernetes, it is going to look at your Kubernetes services and endpoints and lower it to a configuration which envoys understand. Also, if you are configuring Istio route rules or Istio specific configuration, mostly pilot is the one which consumes them and then lowers it to the configuration for data plane. As an operator, this is really great because I'm using your platform language to configure Istio, and I don't have to worry about the low-level details of how the data plane configuration is. You can think about it like in future you can even swap out your data plane, but your configuration remains the same. Mixer is the second piece. In the control plane, Mixer has 3 distinct functionalities that I can think of or I logically think of. First is policy enforcement. So this is a bit tricky and interesting. So how policy enforcement works in Istio is when a request reaches Envoy. So suppose in this case somebody made a request to service A. Before Envoy is ready to send the request to the application container, it will make a check call to Mixer. So that call will include all the request attributes, then the request method, request headers, including the path and user agent. Then the Mixer, depending on your configuration, evaluates whether based on those attributes, the source, the source and the destination and all the request attributes, that request should be allowed or not. Now, and then the result of that evaluation is sent back to Envoys, and then the Envoys enforce it. Now, if you are thinking this is crazy, because if all the requests that are sent have to go out to another networking component, it's going to be really slow. And the architecture realizes that, and that's why all the Envoy sidecars have a cache which store the result of the evaluation. So the idea is Envoy sidecars are going to store for every request attribute what the decision was for the policy, and then the same request comes with similar attributes. It's a cache hit and you don't have to go out. So that's how we gain back some of the performance, but you have the functionality and have the right separation of concerns. Second is the quota enforcement. So quota enforcement is kind of very similar to policy and how it works, but this is related to functionality like how many requests per second a particular service is allowed to make to another service. Third is telemetry, which is very interesting. That gives you all the visibility in your microservices. Mixer is kind of, in my mind, a telemetry sink. What that means is all the stats and metrics are sent from Envoys to Mixer, and then Mixer is the component which is going to integrate with your stats backend like Prometheus, Stackdriver, or StatsD. This is really useful as an operator. Again, it's all about abstractions, right? So if Mixer is the only one which interacts with your stats backend, you don't have to worry about the format of stats from the data plane. So if you swap those out, it doesn't matter. As long as Mixer talks the language of your backend, you're good. Citadel is the third piece. It used to be called Istio auth, and I think before Istio CA. So this is the piece which is responsible for creating TLS certs and keys if you have mutual TLS turned on. So the Citadel will create the certs and keys for all the Envoys. It will also rotate them periodically as and when needed. Again, operationally, I want to reduce the parameter of my security, so I can think of Citadel as the only piece which will integrate with my cert authorities and CAs. So I don't have to expose all the components to those, but only one particular component. All of them are constructed so that you can reduce your blast radius and you can have a nice separation of concerns. The last piece is sidecar injector. So this is the control plane component which is more applicable in Kubernetes. So this is the control plane element which will look at the pods which are coming up, and it will automatically inject sidecar before they are created. So the way it works is the sidecar injector is registered as an admission webhook in Kubernetes, which is a new feature which came in 1.8 or 1.9, I think. It is registered specifically as a mutating webhook, so it's allowed to mutate the objects before they are created. Now, if you're wondering why you want to do this, it's again for operational simplicity. Normally, the biggest problem in any cluster is somebody creating something without the right security parameters and the right proxies around it. Because sidecar injector will automatically inject your sidecar, you don't have security violations. All right. So the last two things which I want to talk about is ingress gateway and egress gateway. So in Istio, just like in Kubernetes, by default, if you put Istio in your Kubernetes cluster, all the services will be allowed to talk to each other, unless you have done some special configuration. But you will always have to do some magic or some configuration to let traffic into your cluster from outside, and to also let services within the cluster go out. So that's where the ingress gateway and egress gateway come into picture. So ingress gateway is the piece which sits at the edge of your cluster. It allows configured traffic into your mesh, and it will send to one of these backend services. Egress is the opposite. So any of the microservices, when they reach out, you can configure it so that all the egress traffic always go through a specific proxy. The reason you will do it is to make sure you can have special nodes and firewall rules for your egress proxy, so you can do deep inspection of the traffic leaving your cluster. We all know most of the security vulnerabilities are traffic leaving your mesh or leaving your cluster. So both of these are currently in Istio also an Envoy proxy, just like the sidecar proxy, but they don't have a sidecar application container running next to it. So they are basically a standalone proxy. All right. Any questions so far? So this is the architecture piece. Next, I'm going to go over the functionality that Istio provides. Yes?
Is there any QRs for the mixer and the Istio control plane to like make sure that you don't run into like a Byzantine general problem where one mixer is like
Good.
corrupted and
So all the mixers, so mixer is currently stateless. So there's no need of doing a quorum. Similarly, pilot is also stateless. Yeah, that's a good question. Thank you.
So, are you going to cover how the Envoy is able to prevent program like service C or service B from calling out to an external service?
Okay, I can cover it right now. Okay, so what I have showed you is the logical view of how the architecture works and how your applications look. So normally when you are creating a new application pod, the Envoy sidecar will be injected. There will be IP table rules placed, which will make sure all the traffic going in and out of your pod always goes through Envoy. So that's the first key piece. And then second, whatever configuration you have given, Envoys will enforce it. So that's why this is so powerful. Like if I trusted my application developer to put it in my application, most probably it's not going to work. In this case, there's no escaping it, right? I mean, you have to do some really crazy things to escape it. Does that answer?
Yeah.
Okay, good.
Absolutely.
Yeah. Anything else? All right. You know, we have some goodies for questions and also some of the answers that you give me back when I ask questions. So our marketing guy made sure we have this. All right. So next we are going to move on to the functionality, some of the advanced functionality that Istio provides, and why would you even care to put this in your mesh, put this in your cluster basically. The functionalities that the service mesh provides is what simplifies and unifies your architecture, right? So normally when I think about the functionality, there are three broad categories in which I split them up. First is traffic management, which is pretty much like this. So the idea of traffic management is giving operators the ability to configure how you want the traffic to flow in your mesh. It's a nice abstraction where as an operator, I am not thinking about individual applications which are implementing a particular service, but I think about when services talk to this service, how my traffic should flow. When a request of particular variety comes, where the request should go. I mean, for me, this was one of the nice concepts when I started realizing it's very powerful. Like, if I am an operator and I am an SRE, I don't want to deal with individual applications because mostly they are not working. Right, that's what the assumption should be. So this abstraction helps you do some advanced functionality irrespective of what the application does. So let's see what some of the functionalities are, right? So request routing. So this is basically looking at request parameters like request headers, request path, your service and destination services, your requesting service and your destination service, and then routing it based on specific configuration. So imagine if you have two versions of a service, version 1 which is providing APIs at /v1/foo, and then a version 2 which provides APIs as path /v2/foo. Now, I'm an operator, I'm going to just configure routes and say whenever you see traffic in this path, send it to version v1, and whenever you see traffic with path v2, send it to version v2. All of this happens without changing the application. In fact, the application not being aware of it is the major power behind it, right? Fault injection is basically a feature by which you can verify the resiliency of your applications. So this we have used in our cluster for testing various things, like what will happen if a service that I'm calling out to has a delay of 20 seconds. Normally everything breaks, but if you can test it without changing your application, that's the key. So with Istio, you can add a fixed delay of 20 seconds for a particular request type, and you can verify how the client would react. In fact, you can verify how in your nested microservices graph, what will happen at the top part of your microservice. You can configure fault injection to add some percentage, add that some percentage of your traffic will be automatically replied with 400s or 500s, and then figure out how your microservices behave, how resilient they are. So the third functionality which is interesting is traffic shifting. Traffic shifting is form of a canary deployment in Istio. So with traffic shifting, you can configure that a particular percentage of your traffic is going to go to a canary version, and the remaining percentage always goes to production. Normally, this used to be a hard thing to do in Kubernetes, and you had to create some elaborate continuous deployment setup. With Istio, it's a simple configuration. The request timeouts and retries are pretty self-explanatory. This is basically configuring when a particular request should be abandoned, irrespective of how the application behaves. So if you have some CLAs that you have to meet or you have to enforce, you can do it at the configuration level without relying on the applications themselves. So these are some subset of the functionalities for traffic management. The next set is, like I was saying, you can control how the traffic gets into your mesh. So that's the ingress piece. You can control what traffic leaves out of your mesh. So this is really powerful, especially if you come from maintaining or controlling or operating a Kubernetes cluster. Kubernetes has no concept of who can talk to what. Everyone can talk to everyone. It's a flat networking space. So this gives you the control, and everyone can reach out also. So this gives you the control that you want to do. And especially configuring all the egress traffic to flow through a egress gateway, so that you can have some nice IDS or IPDS kind of inspection done if you want that kind of control. So the last two features which are very interesting are circuit breaking and mirroring. So I think Daniel mentioned circuit breaking. Circuit breaking is basically making sure you limit the damage of failures. You limit the impact of failures. So you can configure in circuit breaking if a service A talks to service B. If the service A receives 5 consecutive failures, it can eject that particular service out of the load balancing pool. So that way it might give that other service some chance to recover. You can do advanced things in circuit breaking where you can say a particular client is only allowed to make 10 requests outstanding to an upstream service, or it is only allowed to have X number of connections open. When you have these capabilities, you do this outside of your application. So if you see some scaling issues, you can configure circuit breaking and figure out, okay, let's limit the damage and then scale out the applications as needed. Mirroring is also called traffic shadowing. So this is, so the way we use this is very interesting. So if you have some bugs, which most of us have, where you can always produce it in production, but you can never produce it with experiment traffic. You can try with all your curls and magic things and it will never happen again. So what we do is create a new version of our application with all the debug statements and debugging built in, deploy it in production, configure traffic shadowing. So the production traffic still goes to the real microservice, but it is also shadowed to our new deployed service, which has all the debugging built in. So now I can examine what happened. Envoy from the client, because it knows that the traffic is being shadowed, it will it's like a fire and forget kind of thing. So it will reject the response of that request. So it's never sent back. So this is a perfect way to debug some tricky corner cases and actually test and get a feel of things without creating a new setup altogether. Right? This is, I know this is a lot, but still this is not the full list. Please visit Istio docs and look at all the functionality that they provide for traffic management. Any question regarding this? Yes, please.
Does that happen at the TCP layer or strictly?
Very good question. So Istio can, or the sidecar proxies, specifically Envoys, it can parse few protocols. So if the protocol you are using is one of the protocols supported, then you can do routing at that layer. You can also do some primitive routing at TCP, but you don't get the advanced functionality. Right? Anything else?
For a messaging-based microservice system,
Mm-hmm.
would there be advantages using this?
What kind of messaging system are you using?
Like a reactive type of,
So, React?
reactive type of.
I see. So like Kafka or something?
Yeah.
Okay. Another great question. So you're right. Currently, Kafka is not one of the supported protocols. So if you have to use a protocol which is not supported like Kafka, you will have to do TCP routing, and then you're limited in that case. Instead, if you're using HTTP, HTTP2, Redis, gRPC, you get all of this functionality. Right? Even with TCP, it's not like it's not useful at all. You will be able to still whitelist, blacklist things based on IP addresses, but I don't think that's the real power, to be honest. Anything else? All right. So this is a quick illustration of what traffic shifting means. I think you guys already followed and understood what it is. So you have a service A talking to service B where there are 3 pods running. I can configure traffic shifting and say I have a new Canary version running, give it 5% of the traffic and 95%. You can also use it for doing A/B testing if you want to give users some flavor of the new deployment, but you don't want to expose it to the rest of the world. You can say 5% of my traffic goes to the new hotness and the remaining goes to the old one. Simple. All right. So the next functionality that we're going to talk about is security. All right. Sorry. Maybe not. I don't know. Whenever I see this guy, he looks familiar. All right. So security in Istio, I'm going to keep this up and then talk for a bit. Security in Istio basically means how can you secure your microservices environment. Like I was saying in Kubernetes, everyone can talk to everything. So you don't have basic identity verification. Am I allowed to talk? Can I verify your identity? So with Service Mesh and with Istio, once you put this on your running applications, you get the security and the control back. And the best part of this is you don't have to change your applications. The operator can do it. The developer does not have to do it. As a developer, I really don't want to do this. I don't want to have 10,000 times different SSL libraries and deal with it every time, right? I want the infrastructure to handle it. So just like security in other realms, there are 2 key components, authentication and authorization. Istio provides many mechanisms for you to do authentication. Authentication is simply validating the identity of the entities involved in a request. So you validate the client's identity or the servers or both. So the security in Istio work via authentication policies. You have 2 modes of validating the authentication. One is what we call origin-based auth. In origin-based auth, Istio can validate the end user token, so it can look at your JWT or JART-based tokens and confer with the issuer and make sure that they are correctly authenticated. So in this case, it's really powerful because I have worked in cases where you have to change the issuer and now you have to change all your applications. Here you don't have to do that. The applications don't do the validation, the sidecar proxy does, and once the token is validated, it will inject a header with the parsed payload and the application can look at all the payloads. They don't have to worry about who validated it. It's just a header. The second authentication mechanism is what we call peer-based authentication. So in this, Istio provides mutual TLS. So both the client and the server identities are verified. Istio Citadel creates certs and keys for all the sidecars. It periodically rotates them. And then the certificates are constructed so that the identity of each service is unique. The identity of each service is constructed from the service accounts from which the pods are started and a combination of namespaces in which they are started. So there's a protocol called SPIFFE, S-P-I-F-F-E, I think. The certificates subject alternate names or SANs are the SPIFFE document, which is a ID created from a combination of namespaces and service accounts. And then whenever the clients and the servers present these certs, we can validate their identities. It's a much secure way of doing it. And even if you're not using JART or end user authentication, you can just use MTLS and have the security in all the layers, which was previously missing basically. So moving on, the second piece is authorization. Just like authentication and as it is with most open source projects, there are lots of options. So authorization is validating whether a particular client trying to make a request is allowed to access that request or not, right? So the easiest way of doing authorization is basic access control. In this is a form of ABAC or attribute-based access control, I like to think of it. You can look at the request attributes, you can look at source and destination attributes, and then say whether the access should be allowed or not. There is a stronger form of authorization, which is secure access control. In this, if you're using MTLS, you can tell based on identity of the services whether the communication should be allowed. So you can say a client which comes in with a particular identity, that is the only client which will be allowed to talk to the server. So I always recommend, if you're using MTLS, at least use secure access control. The third and the most interesting access control mechanism or authorization is RBAC, or role-based access control. If you're using Kubernetes or operating it, you must be familiar with Kubernetes RBAC, in which you can create role bindings, cluster roles, and you can do cluster role bindings or roles. Roles give basically actions, what resources you can access on the Kubernetes API server, and then binding binds a particular role to a user or robot account. In Istio, you have a similar concept. You can have service roles and service role bindings. Service roles tells you what particular actions a person can take on the service, what requests it can make, what kind of methods it can use, what paths it can hit, and then you do a service role binding, which you can bind to an entity like a user or a service account. So very powerful. I think even though these are a lot of features, I think you should always use Istio incrementally. So if you have no security, add MTLS, then add secure access control, and then maybe move on to RBAC. So this is the quick security architecture which I was saying. Citadel is responsible for managing keys and certs. It gives the keys and certs to the different services or to the envoys. They have a spiffy document. This is the identity, which is a combination of namespace and service account, and then the envoys will validate the identity using this document. So this is the security section. Before moving on to the third thing, are there any questions? All right. So the next category of functionality is policy and telemetry. So quick, just to keep making sure that people are awake. Does anyone know what this is? Andrew, you can't answer that. All right, don't be shy. We have a gift for you guys if you actually know. Sorry?
SETI? Is it SETI?
SETI. No, close. All right, maybe you get a gift anyways. Just for trying. So this is a funny story around this. So I always think of telemetry as antennas gathering telemetry from satellites. So being a novice, I just picked the first image I got. Andrew back there used to work in CU Boulder, and he used to work on some NASA programs. And he told me that someone in the audience will know that you have not picked the right DSN 70 meter satellite. And if you don't, they're going to throw tomatoes at you. You guys are nicer. So this is a 70 meter deep space network array antennas. They are placed in 3 locations on Earth, which are 120 degrees apart, so that all the time when the satellites are sending information, there's at least one of them available. I think they are at California, Madrid, and
That's Canberra.
Canberra. There you go. That's the one I forgot. Thank you. Anyways, this was the sidetrack. So coming back to Istio, Istio provides a lot of telemetry. This is the key thing which helps you understand what's happening in your microservices. As an operator, you need to have a mean time to remediation and a mean time to detection, which are really critical in microservices environment, because it's not just one thing which fails. If something fails, normally it's everything. Like, it's just catastrophic, right? So let's see how Istio helps you in simplifying your microservices with these things. So the first policy thing is rate limiting. I had alluded to it before. This is the quota enforcement, where you can say one particular service is allowed to make X number of requests to the other microservice. You can build some very powerful constructs using this. You can, if you have free tier and a paid tier of microservice, you can make sure that the free tier does not abuse the paid tier. I mean, I personally haven't played around a lot with this, but when I think about it, I think there are some advanced things which we can build around it, especially if you can have some global rate limiting across clusters, so nobody can actually abuse your free tier or your paid tier users, right? So the second thing is distributed tracing. Tracing is, I think, one of the most important things which you need to make your microservices work. So tracing is the key thing which lets you understand which microservices are talking to what, how does different microservices interact, and gives you the ability to zoom in and figure out if there's a performance, where is the latency coming from, where is the failure coming from. With Istio, you get distributed tracing because all the Envoy sidecars, when they get a request, they will automatically create traces for you and send it to a backend like Jaeger and or Zipkin. All the traces which go back, you can correlate them and get the entire graph. So if you have noticed, I've been saying from the beginning, you don't need to change your apps. This is the only case where you need to change your apps. And I have been trying to get this message out for the last 6-7 months that if you need to unlock the full potential of tracing, please update your applications so it transfers the tracing headers from incoming requests to outgoing requests. If the applications don't do, Envoys always create root traces for you. The root traces don't have the hierarchical nature that you want. I have written, I think, 2 blogs. Andrew has written a few blogs. If you visit aspenmesh.io/blogs, you can see how you can effectively transfer these headers. And there are few mines that you want to avoid. So reach out to me or visit those blogs. They might help you. The last 2 functionality in telemetry is metrics and logs. Metrics, I think, haven't changed from the monolith world to the microservices world. They are the key thing to understanding historical view of what's happening. They are the key way to compare when your service was bad to when your service is good. What's the difference? With Istio, you get 2 levels of metrics which are automatically collected, or at least I think of them as 2 separate kinds. First is Envoy level stats. Envoy is your sidecar proxy. It has a unique view into the pod or the application container running in the same pod. It can give you stats about, for a particular pod, how many requests were made, how many requests failed, what was the time. It can give you some of the advanced functionality like how many requests are currently queued, how many bytes are buffered in the connections. So this is what helps you not only detect failures but also predict when you might have failures. Again, you can't actually believe your application to do the right thing here. You need an external perspective to gather this. So I think Envoys do a great job of doing that. The second level of stats are mixer level stats. So mixer gives you a higher level view, which are called service level stats in my mind. So mixer will tell you when a service talks to another service, how many requests were made, what were the request sizes, your response codes. It will give you an advanced histogram of latencies. So this is really critical if you're an operator and you want to make sure that you're measuring your P95, your P99 latencies between microservices, because this is how, once they all add up, you can meet your own SLAs, which is what we mostly aim for, right? The mixer level stats in Istio are configurable, so you are able to add custom stats based on request attributes, and mixer will start reporting them. Currently, Envoy level stats are not configurable, so they are fixed. The last thing is logs. So you can also configure Istio to collect and report some specific logs, which will be triggered based on specific requests, and those logs can be configured to be sent to a backend like Elasticsearch or Fluentd. Right? And again, I think there's a much bigger list on the Istio docs, so please visit that. And this is just introduction, in my opinion.
Can I ask you a question?
Yes, please.
Yeah. So in general, when I've used sidecars in the past, one of the things I can do is I can do queue control logs and then generate logs from the sidecar.
Mm-hmm.
Is that the same
Yes.
apply with this?
You do. So in fact, you have some level of control. So Envoys, the sidecars by default will do access logging, just like Nginx does.
Nice.
So you can get that too. And also you get the tracing if you have tracing enabled, and you get the metrics. So choose what you want. Like it's a Swiss Army knife. Decide what you want and incrementally add features, right?
And then that was the other thing I was going to ask about tracing. So
Uh-huh.
one of the configuration options in a lot of the tracing frameworks that I've had is the ability to sample versus giving me everything?
Great question. So currently, Istio does not have sampling exposed via configuration. It's going to be fixed in 1.0 or later. So you can have sampling turned on. You won't have the right level of configuration where it can make it adaptive or keep changing.
Got it.
That's coming in the next release.
Perfect. Thank you.
Yep. Moving on, this is a quick policy and telemetry architecture. So these are your sidecars. They make two calls to Mixer, check and report. Check is basically when the request reaches an Envoy. Before it gives it to your original service, it's going to check whether via policy the request should be allowed, like I was saying, and there is caching to make sure it's performant. Mixer acts as an abstraction layer with various backends. So you have logging backend, quota backend, authorization, and metrics. So that way, as an operator, you have the nice abstraction for who interfaces with your infrastructure and who interfaces with the data plane. Report is the other call, which happens asynchronously after the request is completed. The report carries attributes like how long the request took, how big the request and response sizes were, what was the path. All of that then can be either logged, or it can be actually the metrics can be created and then sent back. So good. I think I'm done with the presentation part. I have a demo after this, so I can take few questions if you guys have. Yes.
In metrics backend, do you use like Kinesis streams to like send it to a data lake?
Interesting. I would like to say yes, but currently it's not supported. I think the architecture is right for supporting things like what you want. Are you using Kinesis currently?
Yeah.
Can you elaborate on, are you using it primarily for streaming metrics or logs?
It's for streaming metrics to a data lake.
I see. Yeah, I think that's a great use case. Currently it's not supported as a backend, but I'm sure if people want, AWS will be open sourcing it. So anything else? All right. So we are going to move to the demo section. Before I do that, let's gonna set some ground rules. It's a live demo. So there are two things which can happen. Either it will be really interesting because it worked, which has never happened before. I pitched this to my wife yesterday and everything broke. Or it won't work, and then we will do some live debugging and everyone can help me. All right? Okay. So give me some time, I will set this up. Me and this. So the way I have structured the demo is in basically the same way I described the presentation. The first is installation phase, where I'm gonna just quickly show you how you install Istio and what are the caveats that you should avoid, and then go into small demos for each of those functionalities, traffic, security, and telemetry. All right. So let's see. This is gonna be hard to do this. All right, I'm guessing nobody can see this. All right, great. All right, now better if Andrew can see it, or you can see it. Okay, good, but you have good eyes. All right, this is good. All right, there's the second window, which is also small. Quick check that networking is still available. Hey, it is. Your internet is good, man. All right, so let's begin with the installation demo. So I have my demo script here. So I'm going to use this in issue commands. So I have already created a Kubernetes cluster. So the first thing that you guys should be doing is making sure you have the right Kubernetes version before installing Istio. So the way to do this is this. So the key thing to check here is the server version. I recommend using server 1.9 and above. You can use a lower version, but you will have some heartaches, so avoid it. If somehow you will have to use it, you can consult the docs or ask us for help. I think we have been using it from 1.6, so we have gone through all the pains. Next thing, which is really important, is to make sure. Why don't I see my cursor? cursor is incredibly small. Brilliant. So the next thing to make sure is you have the right settings on your API server, on the Kubernetes API server. Key thing is making sure your admission control or the mutating webhook is enabled. So the way you do that is get your Kubernetes API server YAML and make sure you have the right options passed. So in this case, make sure you have admission control and mutating webhook enabled. If you don't have this, your sidecar injector won't be able to inject things automatically. So this is one of the main user errors that I've seen. If many people are using hosted Kubernetes or managed Kubernetes and they don't have this enabled. So if you are one of those people, make sure you have this. All right, moving on. Next thing is you basically follow the Istio docs and you download the latest release. So I have already done the download and I have Istio 08. So what we are going to do is we are going to apply the Istio demo auth YAML. So there are two kinds of, there are many various options basically on how you can install Istio. If you're trying it for the first time, what I will recommend is to use either a Istio auth manifest file or a Istio demo auth. That's a one big manifest file which has everything in one. It also installs for you some of the add-ons like Jaeger, Prometheus and Grafana. So you get everything in a box just to begin. Obviously in production you won't be using this because you will need real databases. Right? So let's do that. So I have also already done this before, but because kubectl is declarative, I can apply it again and hopefully it won't break anything. That's the part which is tricky, but I think it won't break anything. So now that I've applied, which you can see is a lot of resources, we are going to validate whether our installation is correct. For that, the first thing to do is, so Istio will install everything, all the control plane elements in the Istio system namespace. So we are going to watch and see if all my pods and services have come up. So in this case, you can see they are up. If you see the names of the pods, this should now be familiar. You should now be familiar, right? These are the same control plane components that I talked about. So you have Istio pilot, you have mixer, you have the sidecar injector, you have ingress gateway, egress gateway. There are few other things here. Basically, they have split up the logical mixer functionality into smaller pods, which makes sense. So that's why you have some more extra things, and then you have the services which are created for those deployments so that you can talk to each other. So that you can talk to them, right? So far so good. So we have our cluster running and we have Istio installed. We haven't verified whether it's working correctly, but at least all the components are running. All right. So next thing is to verify whether the sidecar injector is working. So the way you do that is you enable sidecar injection per namespace. So the first thing we're going to do is see if any of the namespaces are annotated with this label. The label is Istio injection. All right. So in this case, I have already enabled Istio injection in default. This means any of the pods which come up in default namespace will have the sidecar injector. Simple. If that wasn't the case, you can use this command to add namespaces, add this label to a namespace you want. So this is very powerful by itself because it's an incremental approach to how you introduce Istio in your cluster. You can have some namespaces where you can try things and then move on to other namespaces once it's working. So this guy will fail because I already have the label attached. Doesn't matter.
What happens if you have pods already in a namespace and you...
Good question. I was hoping somebody will ask me that. So Istio is a pure additive function. So those pods work as it is. They don't get any of the service mesh functionality. But what you can do is just delete the pod. If you delete it, the sidecar injector will then inject it automatically.
Okay, thank you.
Yep. All right, so now we are going to see if the sidecar injector is working. The way to do that is create a sample application. I'm going to deploy sleep application, which you can imagine from the name does nothing but sleeps. So this is my deployment which I'm going to apply. It has a service which is sleep and a deployment with just the tum-tum curl image and it's just sleeping, right? So let's go ahead and do that. Alright, so it has created my service and deployment. Now we need to validate that the sidecar was injected. So first thing is this. Alright, so it's creating the pod. It just got completed. If you guys are familiar with Kubernetes, this should look different. It is actually running 2 containers instead of 1, even though my deployment manifest said just 1 container. So that is a good signal that the sidecar has been injected. We are going to do more validation actually, and we are going to look at the pod manifest and see what happened. All right, there you go. So this is the pod spec. You see this is the container that we wanted, the sleep container. The sidecar injector automatically injected the second container. This is the sidecar proxy. There's a bunch of command line options which also it automatically added, and this is the image. So I'm using Istio 08. So this is being pulled and everything is created. Cool. So this is the first demo which worked. I'm surprised. All right. So these are some of the things that you have to make sure that before you start using your service mesh, it's actually in a state where it's usable, right? Any questions on this? I think I'm doing good on time, so. All right. So the second part of the demo is to do a traffic management. All right. So these things are going to be interesting. All right. Cool. So to get the traffic management demo, I have to deploy an app. I'll deploy an app which feels like a microservices app. So the app I have chosen is Bookinfo. Anyone familiar with Bookinfo? Right. Everywhere you see it. I'm sorry. It works. There you go. All right. So before I actually deploy it, let me show you what the structure of the microservice deployment is. Okay. So this is the Bookinfo application. It has 4 microservices: product page, reviews, details, and ratings. So whenever a request comes in from Ingress, it goes to product page. Product page makes a request to reviews. There are 3 versions of reviews running. So without any other configuration, Envoy will load balance across them. The difference between the 3 reviews are: reviews version v1 does not call out to ratings. Reviews v2 makes a request to ratings but shows the ratings as black stars. The reviews v3 shows the ratings as red stars. And the details page, details is the microservice contacted by product page to get details of any book. And just like microservices, just to show the versatility, all of them are written in different languages. They're pretty stupid apps, but it serves a purpose. All right, so let's see what the Bookinfo deployment looks like. So this is the Bookinfo manifest. As you can imagine, it has services for each microservice and the deployments for each of them, right? So first thing is we are going to go and create them. All right. Wow, this worked. So we want to make sure that the sidecar is injected in all of them. Otherwise, all the demos, none of them are going to work. Good. So all the containers are being created, all the pods are being created, and they all have 2 out of 2. So I'm convinced that they have the sidecar in them. All right. All right. So like I was saying, in Istio, without any configuration, all the services are allowed to talk to each other, but nothing will be allowed to go into your mesh. So to get traffic into the mesh, I'm going to create Istio resource called a gateway. All right. So for any kind of traffic that you want into your mesh, you have to create these 2 resources. First is gateway. Gateway is a logical abstraction about specifying layer 4 policy. So this one says, I want to expose port 80, which will be the protocol HTTP. I'm going to expose a host dcc.demo.aspenmesh.io. I have already created a Route 53 entry for this. So if you have laptops or phones, you can actually go to this and you will be ahead of me in the demo. Hopefully you won't break anything. I shouldn't have said that, I think. So, and the interesting thing it does is it provides a selector. It says use the Istio ingress gateway. So this is a nice logical separation. If you're familiar with configuring big IPs or some sort of network devices, this is how you specify things. And the second thing is a virtual service. So virtual service is always tied to a gateway. In this case, we are going to tie the virtual service book info, which has the same host. So that's the most important thing. All these resources are mapped by hosts. So it says for the same host, tie it to the book info gateway. And now I'm saying what is the traffic that I want into the mesh. So the traffic I want is I only want GET requests and I only want product page and API v1 products into my mesh. And whenever you see a traffic with this host, these methods and these URLs route it to this destination. All right. Anyone tried going to that? Is it working? It shouldn't be. If it is, then something is wrong. All right. So I'm going to use istio.ctl and create it. So if you are noticing, I'm switching from kubectl to istio.ctl. There's a reason. Istio.ctl provides a first level validation for all your CRDs. Always use istio.ctl if you can for Istio resources. It saves you a lot of time in debugging. So let's try this. Okay. So I've created the gateway and the virtual service. So now I want to browse to this guy and see if it actually works. All right. Of course it doesn't. What happened here?
So is this the alternative to ingress controlling or using like an
Yes, it
ingress
is.
control for Istio?
All right, something is happening. Good, it worked. So Istio used to support in 07 and before the ingress, Kubernetes ingress resources. Ingress resources are a special kind. They are good for some reasons and for some use cases, but for advanced cases they break. They don't have the right logical abstraction where layer 4 and layer 7 are different. These resources in my mind do that. So there you go. So now I'm able to route traffic into the mesh from external sources. So if we keep refreshing, we should see different versions. So this is version 1 of the reviews where there is no ratings. Refresh again. This is version 3 or 2 I think, with the black ratings, and then hopefully we'll see the red one. There you go. Okay. So this is, I have just enabled ingress traffic. I didn't have to change anything within the mesh, and all the routing happened. Let's get funky. What are we gonna do? All right. So because we had configured a specific method, what do you think? This is gonna work? Trying with head requests, that shouldn't work, right? So let's see. All right, great. So whenever Envoy does not know what to do with a particular request, it will say 404 not found, because I only configured it to accept GET requests. If I change this and make it a GET request, hopefully it works. Oh, there you go. So this worked. There were 2 APIs which I exposed, API v1 products and product page, right? All right, so the next thing what we are going to do is we are going to configure Istio so that all the traffic goes to version v3 of the review service. That means you should just see red stars. Yeah, I think that's the right color, we'll say. So let's see what this route rule looks like. All right. So you're creating a virtual service. Now you're saying for any request with the host reviews.default.service.cluster.local, which is the fully qualified domain name of all the services in Kubernetes, route it to destination, that service with the subset v3. So subsets are powerful constructs in Istio where you can create a selection of your services based on labels. So then I have to create a destination rule which will say the definition of my subsets. My subset v3 is labeled with the version v3. My subset v1 is obviously with v1 and v2 is v2. And because I deployed Istio demo auth, I have to explicitly make sure that I'm specifying the TLS mode Istio mutual. If I don't do that, it's going to fall back to no TLS and nothing will work. So let's apply this. Again, use istioctl to create the resource. All right. So if this worked, we should just be seeing red stars on every refresh. There you go. So now it's not load balancing across all the 3 versions, but just using the simple version v3. So you can enhance this further and you can do some traffic shifting or canary deployments. So that's the next thing which I want to show, which is this. So I can change the same virtual service configuration which I had before. Now I am going to say route 75% of my traffic to subset v3, which is the same as the old one, but 25% to v2. So that means 1 out of 4 times we'll see roughly black stars and 3 out of 4 it will be red stars. So I'm going to use this and replace the existing deployment. Alright, so this is done. So when I go here, there you go. It's roughly 1 out of 4. Alright, this is the first time book info has worked in my favor. Alright, so this is the traffic management demo. Second or the third demo I have is the security demo. You guys still with me? Alright, good. Alright, so what we are going to do is we already have MTLS, but now we want a higher level of security. We want RBAC. I want to make sure specific services can only talk to specific services on specific paths using specific methods. So let's see how we do that. So I'm going to create this manifest. So Istio for RBAC and anything related to Mixer has the concept of instances, handlers, and rules. So instances are basically an instance of a template. In this case, I am enabling an authorization template. I am making sure the template has access to these properties. So it will have access to the namespace, it will have access to the request method. So the handler, which is the RBAC handler, can use any of these properties to verify whether the request is allowed or not. Then the rule is the thing which brings the handler and the template together. So the rule says whenever anyone is trying to talk to the default namespace, invoke the handler RBAC and then use the template instance authorization. So this is a little complicated because it's so flexible, but it enables you to create powerful things where you can have different template types which will validate different things. If you just created a one document, it won't give you that flexibility. All right, so let's create this. All right, so this is done. So this is the part of the presentation where you get a gift if you answer this question. All right, so what happens after this? I have just enabled RBAC in my cluster, and in the book info I have product page was supposed to talk to reviews, product page was supposed to talk to details, and reviews will talk to ratings. All right, guesses. What's going to happen?
Work.
It will work?
No, it won't work.
Okay.
Because you just enabled RBAC. Right?
So what does that mean? Why won't it work?
Because you haven't said, hey, what work can you
There you
talk
go.
to work?
All right, man. You need to give him.
Free shirt. That's awesome.
Thank you. All right. To prove that, if anyone has already gone to this web page, they can decrease my anxiety and tell me whether it worked or not. But if not, let's try it. Hey. This is getting going. All right. So this is getting permission denied. Exactly what he said, right? So you have RBAC enabled, but you don't have any explicit permissions granted. So this is what we want. We want incremental security. All right. So the next thing is we are going to enable specific RBAC rules. All right. Remember I was telling you, just like Kubernetes, you have service roles and service role bindings. Service role defines the rules and actions. So in this case, it says for any service in the default namespace, allow gets, as long as it has the app label product page details reviews ratings, which is the collection of services we have. Then the service role is being bound to specific subjects, and the subjects are anyone from namespace default can talk to these services, and also anyone from namespace Istio system. Any guesses why you need Istio system here? Kind of, but in this case, you need it because the Istio ingress has to talk, right? You're right. Otherwise, you won't be able to get the traffic into your mesh. All right, let's see. Let's create this. All right. No guesses for what happens now, right? It should work. There you go. So now we are back. We are doing 25% to black stars, and I think, yeah, 75% to red ones. Cool. So this is the security demo. The last demo I have, bear with me, is the telemetry one. So Istio by default is gathering a lot of tracing and metrics. So what we can do is look at what the tracing gives you. So I have already created a domain for this, and this is pointing to the cluster that I'm running. So what I can do is do this. So since we were already sending a lot of traffic, we get all the tracing information from Jaeger. So let's zoom in, and this is what you want to see, right? You want to see a nice hierarchical graph of the services talking to each other. So product page talks to details, product page talks to reviews, reviews talks to ratings, and then once in a while you will also see the Istio policy check calls, because so all right, you want to make it bigger? Oh, sorry, I didn't realize it was so. All right, better? Okay. So the policy checks here are basically whenever the Envoy has to contact the mixer for enforcing policies. Because these are cached, you won't see them every time, but you'll see them only when the caches are expired. So this now gives you the hierarchy of how long your requests are taking. You can clearly see from product page to reviews is 30 milliseconds. Probably it's a bad app, but shows what we want to do. All right. And the view here is an overall view in whatever you queried. So this gives you the y-axis is latency and the x-axis is time, and then the size of those bubbles are basically how many traces they have. All right, the last thing is to look at Grafana, which gives you all the metrics from Prometheus. So we are going to do is port forward, and then this is not the one. Go here. So Istio comes with a Istio dashboard, so we can go to that dashboard, and then this is going to give you what your services look like. This doesn't look that great yet. What I'm going to do is going to run some traffic. So I'm going to use this command to generate every 1 second traffic to the URL, and that is working. So now you will see these things are gonna get filled in. So globally it gives you how many requests are being made, whether they are success or not. The 1% is because of the time when I had RBAC enabled, but it actually didn't have any rules. Then if you go down, it gives you per service view for every service, how many RPS, what's the request per second, whether it had success or failure, response times, and you can create cool latency graphs with P95 and P99 evaluation. So all of this is done for you. You don't have to do it. as an operator. All right, so I think this ends my demo. Wow, it worked. All right. Any questions? Yes.
Two questions. I noticed using Istio CTL. Can you use kubectl?
Yes, you can.
Kubernetes?
So there's a reason I'm using Istio CTL. Istio CTL will do validation of CRDs, which kubectl won't. So if you're new to writing Istio config, it's better to use Istio CTL. If you use kubectl, it will just blindly accept it, and then you will have failures later down.
What version of Istio were you running?
This is 08.
So I've been playing with 1.0 snapshot. It looks like they actually fixed that. So I thought that was pretty
They fixed it so you can kubectl will do.
Apparently, I've tried a couple of
Okay.
route policies, applied them, and they actually picked it up on kubectl.
Oh, that's
So
great.
it's pretty cool.
That's great. I mean, yeah, they're making a lot of improvements in 1.0, and usability of Istio is one of the main things.
And then second, you feel that Istio is production ready? Can I use that in production yet?
Interesting. So Istio is definitely 1.0. I don't think it's production ready yet. Now, 08 was a great improvement over previous releases. 1.0 I haven't had my hands on, so I won't say whether it's production ready or not. They have fixed various issues which were critical for production deployment, especially around scaling control plane and some of the configuration complexity. So it's improving. I think we should wait for 1.0 to come out, and if you reach back to me in maybe a week or 2 weeks, I can give you my analysis of whether it's production ready or not. Yes.
So talk to me about if I've got multiple clusters.
Mhm.
Can I mesh those together, or
All right.
do they have to be? Do I have to go through ingress and egress to go through that?
So, two questions for you.
Yep.
Do you have multiple clusters now?
Yes.
How are you handling routing between them?
Manually and badly.
All right, thank you. So, in Istio, there is a concept of mesh multi-cluster, not mesh expansion. So, currently, so there is how it works currently, and there is how I think it should work in the future. I'm going to give you how it works currently. So, you can have multiple clusters talking to each other. The way you will do it is you will have one master Istio control plane. All the clusters have to be in the flat networking namespace kind of, so they can't have conflicting IPs. So the control plane or the palette will discover everything across the clusters, and then you can transparently talk between them. So you don't need to explicitly go through ingress or the egress gateways, but you can configure it if you want policies. In future, I think how it should work is a federated model where you will have control planes which are responsible for individual clusters, and there is a high level configuration which specifies who can talk to what. I think you have the right resiliency and HA semantics when you go to that model. I don't think it's coming out in 1.0, but I think there is some work going on. Anything else? All right. So I think my marketing guy will kill me if I don't give a Aspen Mesh pitch. Is that okay for the last 5 minutes? Go for it. All right. Okay. So whoa. All right. So I am part of the Aspen Mesh team. I think 4 of us are here. Catch us if you have more questions. So we are a supported service mesh. So we have 3 main, which is built on Istio. So we are 100% compatible with Istio's API and open source Istio. So we have 3 broad categories of advanced functionality that we provide on top of Istio. So first we have support. So we test and test and release our own version, which is based off Istio, but we version them separately so that we skip few versions if they are sometimes broken, which have been in the past. The second is we have a hosted SaaS portal, which gives you benefits of we host Jaeger, Prometheus, Grafana for you. So all the things that I showed you, if you have to really deploy it and use it in production, you will have to manage 3 databases for yourself. With us, we manage those for you and we host them. So you will get access to all of these things, but you don't have to manage it. We run advanced analytics on that platform. So this looks at all the telemetry and the tracing and give you high-level view about service health, about if the security is broken. I'm going to go into details into a little later. And the third piece is we are sort of a configuration management for Istio. So we make it easy for you to run Istio by giving high-level configuration objects which abstract away the, like at least in this demo I showed you 10 to 15 different configuration resources. You don't have to do all that. So the way it works is you still have all the Istio control plane elements in your cluster like you did before. You will install an Aspen Mesh agent in your cluster, which is yet another control plane element. The agent collects all the telemetry from the mixer and envoys, including tracing, and all the config, and it sends it to a hosted platform, which the dashboard can use to give you analytics. And you can also have higher level policies which your dashboard, which via dashboard you can configure, and those policies are then created automatically by the agent. So you don't have to create all the Istio route rules if you want. So this is how the how our dashboard looks. Alright, so this is set up in our demo cluster, which we use for demoing to customers normally. So what you have here is the top panel tells you whether your agent is actually healthy. So if the agent is healthy, that means agent is sending information up, so we can actually do analytics for you. This is the next section, which is the service graph. So this tells you how your services are talking to each other, and this is based on the last 5-minute interval. The logs show you if the MTLS is currently working. So these green logs will turn red if somehow if you have configured MTLS but some traffic is going without MTLS, or if your certs have expired and somehow there's some communication which is broken down and you can't get new certs. So this will turn green from green to red, and you will get information about them. So the service health tells you whether your services are healthy. So right now reviews seems to be unhealthy. If you click on it, it will tell you why it's unhealthy. 67% of requests are taking around 700 milliseconds, which is way longer than what you want. And then the second section gives you security information about the cert. So it's saying each of the pods are using certificate with this identity. Can you see them? Whatever. And these identities, if they are different, mostly kind of tells you that something is broken in your cluster. Like they might be aged out and there is some communication problem. So the last thing is Aspen Mesh experiments, which is kind of a high level configuration. So configuration management that we give you. So with Aspen Mesh, you can create experiments. These are a way of running experiment services in production securely without having to spin up yet another staging or testing environment. So if you have a new version of microservice that you want to test, you will spin up experimental version in your production cluster. Because Istio is installed, there will be by default no traffic going to it. Then you create an Aspen Mesh experiment. Once you create an experiment, the agent automatically creates the route rules where it makes sure only the experiment traffic goes to the experiment service and the production traffic goes to production. To generate experiment traffic, we give you a unique token which you're going to use to generate traffic. And then once you are convinced that the experiment is working, you can even use it to shift some of the production traffic. So you can do canaries with it, and then this gives you how your experiment is doing compared to production. So this is in a nutshell Aspen Mesh. If you need more information, please reach out and contact us. Or if you have some questions around Istio, I'll be more than happy to answer. Thank you. Few minutes.